an array of integers, say a. This also falls into the category of search problems, and we're going to use hashing as a solution mechanism. The problem statement goes like this. Given an array of integers, say a, find an element k which is not present in the array. In A. So that's a very interesting problem, because till now the problems that we have solved, all of them actually involve searching for an element in an array, and most of them we have used either hashing or binary search techniques. Now this is interesting in a way that you are looking for an element that is not present in the array. And how can you do it? The best approach would be to use a hash table. Now suppose I will give you a couple of techniques. One technique is just search the array, or not even search, just go over the array once and search for the maximum and minimum once, and note down the max and min. Max and min. Then obviously you can return max plus 1 as an array that is not, as an element that is not present, and also you can return min minus 1 as an element that is not present in the array, because we have already gone through the array and these are the extremes. Now this technique won't work in one case. The case is when the max is really the maximum integer possible for that specific representation of integers. So if max is the max integer, which is 2 to the power 32 minus 1, or min is the min integer, then it won't work. This technique doesn't work, because you cannot return max plus 1, because that will cause overflow. Similarly, you cannot return min minus 1, that will also cause an overflow or underflow. So this does not work in those cases. Now the other approach is to build a hash table. Build a hash table with the following. So you have this hash table, and the key is really the value in the specific index. So a of I is the key, and the data is the index I. So what will happen is, you will fill up this hash table as you go along the array, and at the end you will end up with a hash table with all the keys and the data, and all you have to do is just go over linearly the hash table and see if any key is missing. If a key is missing, that means that element is not there in the array. So the complexity of this algorithm is you have to go over the array once plus the size of the hash table that you chose. Now the size could be fairly large, because if you're looking for 32-bit integer, you may have to do it 2 to the power 32 minus 1, or 2 to the power 32 minus 1, 0 to 2 to the power 32 minus 1 entries in that. There are ways of reducing the size, so you may not do it straight away. You can actually split the hash table into two, so each hash table becomes 2 to the power 16 minus 1. You first do that, and if you don't find anything there, every entry is occupied, then you do the next one. For the first one, you take the MSB 16 bits of the integer. For the second iteration, you use the LSB 16 bits of the iteration. But this gives you the basic idea. So basically you map it to a hash table, and if you have a missing key, that means that element is not there. Hope you enjoyed the solution. We'll get back to you with more such problems in future. Bye.